Alright, hi everybody, welcome to lesson 5D, distance time graphs. Okay, so we are going to still talk about lines, however, we are now going to analyze it from a distance time perspective. Okay, now we are going to look at not just one line this time, but several lines to simulate a distance time situation or scenario. So let's take a look at number 1. Graph the following scenario. So if this was in class, it would be a lot easier to show you this. A visual really helps in this case. But since we are not, this will have to do for now. Then we need to make this a little smaller. Okay, so Lij is at home. Okay, so probably because Lij is quarantined. So Lij is at home. If I look at the y-axis, in this case, our y-axis represents the distance from home, okay? And this time will be time in seconds. So at 0 seconds, how far is Lij from home? 0 meters, correct. So Lij starts at 0 meters. Now, it takes Lij 6 seconds to travel 4 meters from his house. So 4 meters, 6 seconds. So 6 seconds, 4 meters, okay? So that means after 6 seconds, Lij is 4 meters away from home. So let me just draw a line that connects those two. Okay. Sorry, I'm just going to match up the colors. So Lij is at home, okay, and it takes 6 seconds for Lij to travel 4 meters from his house. So 1 second, 2 seconds, 3 seconds, 4 seconds, 5 seconds, 6 seconds, and how far is he? 4 meters from his house. Alright, now let's take a look at the second part. He decides that those 6 seconds were extremely exhausting, so he rests for 6 seconds. Now if you're going to rest for 6 seconds, are you going to travel anywhere? No, you're staying put. So if you're staying put, that means for the next 6 seconds, what's your distance from home? Still going to stay at 4, isn't it? So after 1 second, 2 seconds, 3 seconds, 4 seconds, 5 seconds, 6 seconds. Okay. So at 12 seconds, he is still 4 meters away from home. So I'm just going to draw a line connecting those two. Let's see if I can change the color of my line. Maybe? Oh, yes I can. Perfect. Line color red. Okay. So from here, oops. Here to here. Okay. So rest for 6 seconds, represented by the red line. Okay. Now, last part. Let's go with blue this time. He then realized he forgot something at home. So, he forgot something at home, which means he wants to go back to 0 meters per second, right? So, would I go straight down? No. Unless I can teleport, which takes no time, there's no way for me to go from 4 meters from home to 0 meters from home in no time. Okay? Now, he then realizes he forgot something at home. So, he travels at a speed of 2 meters per second. Okay? That is what we call a rate of change. So, in 1 second, he travels 2 meters. There's also an S word that we learned, and that is the slope. So in this case, we're traveling at 2 meters per second all the way home. So he gets up and realizes that he forgot something. So we have to travel at 2 meters per second. So in 2 meters, so from 4 meters to 2 meters, how long did it take? 1 second. Okay? 2 meters, 1, 2, and 1 second. Okay? So here's the last line. The blue. And there we go. And we're done. Okay, so this distance time graph represents this scenario that Lij went through. So Lij is at home. He takes 6 seconds to travel 4 meters from his house. 6 seconds travels 4 meters. He then decides to rest for another 6 seconds. So he does not go anywhere for 6 seconds. And then he heads home at 2 meters per second. 2 meters, 1 second, 2 meters, 1 second. Done. Okay? How much time has passed when he returns home after he has left his house in the first place? Well, how much time has passed? The whole trip took 14 seconds. What was the total distance that Lige traveled? Well, what did he do? He really only traveled 4 meters away from his house. They didn't travel at all, and they must have traveled another 4 meters to go back, right? So the total distance would be 4 plus 4, 8 meters. What was Lige's rate of change or speed before he took his 6-second rest? So what was his rate of change here? Another word for rate of change is slope. Rate of change equals slope. Okay. So what was the rate of change? Well, let's see. From here, we traveled 4 meters in 6 seconds. So what was the rate of change? You can say 4 meters in 6 seconds. And yes, I would prefer if you simplify this, but that's for another day. For now, I'm okay if you just left it at 4 meters per 6 seconds. 4 meters, 6 seconds. Okay? Now, could you have said, for this one, instead of 4 meters per 6 seconds, could you have said 1 meter in about 1.5 seconds? Sure. You could have also said 2 meters in about 3 seconds. Okay? They would all be roughly the same. What is the slope of the first line? The line representing when he initially left the house. Well, like we just said, it would be 4 over 6. Okay? Or you can say, and it's the same answer as here, 4 meters 6 seconds. You can simplify this, divide the top and bottom by 2 to get 2 over 3. Okay? Now let's take a look at this next example. Let's see. I'm seeing if there's any of these questions that I should go through. You know what? Okay, here. I'll leave this one for you to do on your own. Brandon starts behind his own net. So distance from his own net, so 0. He skates up the ice traveling 25 meters in 7 seconds. 25 meters in 7 seconds. He had his head down so he gets hit, and he lies on the ice for about 5 seconds. He looks up and sees the guy that hit him and chases him towards the other team's net in about 4 seconds. So the other team's net would be going up this way. Why? Because that would be the furthest distance from his own net. Okay, traveling about 35 meters. Yeah, so give this question a try. The questions down here are very similar. I do want to do number 2 for you, because, or this question, sorry, the numbering is all wrong. But I'm going to do this example for you so that you're able to do the last one, okay? Or you should be able to anyway. Okay, so looking at this question, Angelus lives fairly close to school. She usually bikes there. On the distance time graph illustrated, indicate any and all intervals where her speed is the slowest. Okay, where is her speed the slowest, but not 0? Well, clearly here, this section right here is when the speed is 0. Okay, so let's try to make sense of what's happening here. Distance from school starts at home. He bikes, or she bikes towards school, and all of a sudden turns back and goes home and rests. Maybe she went home to use the washroom or something. Then sped up and really fast to get to school, and I stayed there. Okay. So where does it look like she traveled the slowest? Her speed is the slowest. Well, let's see. In this section, from here to here, you want to see between this line, and this line, which is the steepest. Okay, steepest would mean the fastest, sorry. So which one is the least steepest? Well, if I look at this first line from, let's call this 0, from O to U, how much did we travel? Not a whole lot, but it took a lot of time, didn't it? Whereas here, it traveled the exact same distance to go back home, but in less time. So it would make sense that her speed is the slowest between O and U. Okay. Now, how about when she is riding away from school? Well, she starts going to school, and then she starts going home. And then stays, and then goes to school. So, between U and Z, between is when she's riding away from school or going home. Between U and Z. When she's not riding her bike. Well, here she stayed at home for a bit, so clearly she's not moving, so maybe using the washroom. So between Z and, I can't see what letter that is, Y. Okay, so between Z and Y, and also when she gets to school. Also, X and W. When is she at school? Well, I just answered that, X and W. Okay? Any further questions, please give me a shout under math questions, and I'll answer as quickly as I can with a video. Okay? Take care. Bye.